Physics students, Mr. Fugit here. In this video, we're going to be looking at another problem from your homework number 1, which covers over density. This problem is going to be the last problem on your homework, which is titled Density 000C, and it does have two parts. We're going to be looking at both parts. The first part will be covered in this video. The second part will be covered in a subsequent video. So, let's look at our problem statement together. It says this: I find a ball bearing in my classroom, something that we've dealt with before. The mass of the ball bearing is 182 grams. I'm going to make a quick note of that. Mass of my ball bearing is 182 grams. And the radius is 0.5 centimeters. So I'm given a mass, and I'm also given the radius of my ball bearing, 0.5 centimeters. Okay, let's see if those pieces of information will be helpful later on. Given that information, what is its density? It being my ball bearing. So what I'm looking for here is the density of my ball bearing. Density, rho, is equal to, well, we don't know yet. That's what we're going to be looking for. So, as we go through this problem, as we will for all of them, notice that the values that I give you are simply the values that I have for my problem. Your value for mass and your value for radius will likely be different than mine, okay, but the process will be the same. So as we go through, feel free to pause, stop, fast forward, or rewind, depending on how you are feeling with the problem. If you encounter any questions as you work through this, stop, send me an email, send me a message on my mind, and I would be happy to get back with you. Okay, so back to our problem. It says this: now that we're given our mass and radius, what is our density? Well, we know that density, we have an equation for density. It's the relationship of mass over volume. Well, if I'm looking for this variable here, P, density, well, it's really a rho is what we call it. And I'm given my mass, M, but I don't have my volume, V. So, looks like what I need to do here is I need to find my volume and use the given mass to solve for density. So, let's come to a new page and see if we can solve for our volume. So, here on our new page, we know a few pieces of information about our ball bearing. We were given a mass as well as a radius. We also know that this is a ball bearing. So the shape that that ball bearing has is what we call a sphere. And we have an equation for the volume of a sphere, V, and then SPH for sphere, is 4/3 times pi times the radius of our sphere cubed. So really, when we're dealing with the volume of a sphere, the only variable that we need is our radius, r. Unfortunately for us, we were given that radius r in our problem statement. So now, I'm just going to plug in the values that I'm given. So volume, V, is equal to 4/3 times pi times my radius, 0.5 centimeters cubed. So I'll take just a moment. I'll plug this value into my calculator. We have 4/3 times pi times 0.5 centimeters cubed, or to the third power. So it looks like when I plug all of those in, I should get a value that looks like this. My volume, V, is equal to 0.5235 and then a bunch of numbers. But remember, when we're dealing with presenting an answer, we can round to 3 significant figures. So that will look like this: 0.52, and then my next number, 3, is followed by a 5. So I'm going to round this up to 524. And my units here were centimeters, but I cubed those. So my overall units would be centimeters cubed. So now I have my value for volume, V, which is the other part I needed to solve for my density. So let's come to a new page, and we will see if we can plug in what we know to now solve for density. So here we are. We now have a value for our volume, V, which we just solved for, which was 0.524 centimeters cubed. We also were given a value for our mass, which for me was M, a mass of 182 grams. So now that we have mass and volume, we can use those two values to solve for our density. So let's plug into our equation. Density, rho, is mass, M, over volume, V. We know that our mass is given to us as 182 grams, And then our volume we determined to be 0.524 centimeters cubed. So we now have our mass and volume. Let's plug these values in to get a value to see if we can solve for density. So 182 grams divided by 0.524 centimeters cubed is going to give me a value of volume that should look something like this. Density, rho, is 347 point approximately 59, we'll round that to 6 grams per centimeter cubed. That should be my final answer there. Now again, your value is going to differ based on the numbers that you're given. But I should get something, and I'll check my answer key here. Good. So what I see is that my answer key tells me my value should be 347.6 grams per centimeter cubed. So here, just as a quick review, what we did was we used our radius to find our volume, V, which you'll see up here. And then we used that volume, as well as our mass, to solve for our density. That's going to be our process in solving here overall for the density of our ball bearing. Again, if you have any questions, don't hesitate to ask. Good luck.